behind the probability ones. It's the last one in the packet I gave you. Okay. This lesson is called the binomial theorem. It's actually in the sequence chapter, chapter 10, because it is on, sequences just are patterns of numbers, okay? This is a really cool, in my mind, because I'm a math teacher, pattern of numbers called Pascal's triangle, okay? But it is also the application to binomial probability, which is part of today's lesson, so I moved it to the probability lesson, or the chapter. Part of the reason for that, I don't know if anybody can see this, but this is my lesson plan book for this week because of all the testing, okay? It is one big scribbly hot mess because we've moved so many things the last few weeks. So, this is where this landed. We're going to do this lesson today. The binomial expansion part of this is cool. You take more math in college, you may use it once or twice, but the binomial probability has real applications, okay? This is what I want to show you first. Am I recording?
Yes.
Okay, thanks. The timer's moving. I didn't see it. Why do I have this over the top? I just want to slide this down. Here we go. Add a page. Okay. Everybody, eyes up here real quick. This is a review. I need you to follow along so that this makes a little bit of sense where some great mathematician figured this out. If I write this, what do I get? You're scaring me. Anything to the 0 is 1. If I write this, what do I get? Where the coefficients are. Okay, if I write this, a squared plus 2ab, right? Because there's an ab plus another ab plus a b squared. The coefficients are 1, 2, 1. We good? All right, I'm going to go over here and write small. A squared plus 2ab plus b squared times another a plus b. If I FOIL that out, I get a cubed plus 2a squared b plus b squared a plus, I'm distributing the b now, I get an a squared b plus 2ab squareds plus b cubed. Okay, some like terms. I have an a cubed. There's 3 of these, right? Back here, I wrote that one backwards, but ab squared and 2ab squared is... What were the coefficients? Okay. Row 0 had a 1. Row 1, 1, 1. Row 2, 1, 2, 1. Row 3, 1, 3, 1. This number here matched this number here, yes? Okay. If we just write down the coefficients, we get this. Can you tell me some patterns you see here? This diagonal is always 1. What else do you see? This diagonal is 1, 2, 3, 4, 5. It also matches the row number. Yes? Okay. Let's try again. All right. The next thing that most students find interesting is if you add these two, you get that one. If you add these two, you get that one. You add these two, what's the next one going to be here? So we start with a 1. The next one would be 5, 10, 5, 1. Okay? What do you notice about this line down the middle? It's going... what I wanted you to notice was that it's symmetric on either side. Okay? Do you see that? This one goes 1, 4, 6, 4, 1. This one has an even number of terms, but it goes 1, 5, 10, 10, 5, 1. Okay? If we wanted, remember we did combinations yesterday? Does everybody remember this? NCR, and we did n factorial, n minus r factorial times r factorial. This is, for example, I'm going to choose in this class 2 people to hand a $100 bill to. Doesn't matter what order you're chosen, so it's 26, choose 2. Remember doing that on the calculator? It was under, you got to put the 26 in first. What am I, got a mess here. There we go. 26, math, over to the probability menu, down to choice 3, and you type a 2. If you happen to have the color calculator, and only the color, it's under alpha, window, and there's one, choice 8, and then you actually get to put in your 26 and your 2, but it's not on anything but the colors that you can do that. All right, so that was how many ways I could pick somebody out of 2 people out of this class to give this to. What does that have to do with this? Well, if I wanted to know row 10, everybody paying attention? Row 10 is going to be this. I don't want to count down there and do them. It would go 10C0, which is going to give you a 1. Then it would go 10C1, which is going to give you a 10. Then it would go 10C2. Can you find out what that is on your calculator? Now, do second enter so that you don't have to retype that, and tell me what 10C3 is. Second enter, and then you can just change the 2 to a 3. What'd you get? This was 45? Okay, thanks guys, didn't hear you, my bad. 120, okay. 10C4, how much? 10C5, 252. Okay, now we're going to start to repeat. And I know this because, stop for a second and think about this. The way to choose 4 winners out of 10, the number of ways that can happen, is the same as the way to choose 6 winners out of 10. Let me think about that. Okay? If there's a bag with 10 names, the ways I can pull out 4 and they win is the same way I can leave 6 in the bag and they lose. Does that make sense? The number of ways that can happen is the same thing. Okay, if you didn't know that and you just typed it in, you'd get 210 and then you'd realize the symmetry starting, right? So the next one is going to be 120, 45, 10, and 1. All right. I'm not going to ask you to do that, but that's how you come up with those numbers. I had my son's teacher one year told him they needed to write down the first 35 rows of Pascal's triangle for homework. That was row 10. Okay? And if you didn't know how to do it with combinations, and you're just doing it adding the 2 above, how many rows do you think before you make a mistake? Because the next row has 3-digit numbers, and the next row, they get really, really big really soon. Okay? My point is it was ridiculous. You would have needed a piece of paper the size of this floor to write down the first 35 rows. Okay. Moving on. Did we talk about the exponent powers? As we did this, if I go back here real quick, what do you notice? I didn't go very far. Let's do the next one using this idea. What is the 4th row, guys? Goes 1, 4, 6, 4, 1. Okay, now watch. This had a squared, a to the third. This one is a to the fourth. That goes down every time you go across. So this becomes a to the third, a squared, a, and no a's. Going back the other way, there's 4 b's, 3 b's, 2 b's, 1 b, no b's. Okay. What do you notice about the sum of the exponents every time? 4, 4, 4, 4, 4. You see what I'm talking about? Okay. Yes. There's a golf question today. All right, we're going to skip all the way to this question. Going to start working you. What row do I need? This power tells me I need row 3. Do we have row 3 memorized, or do we need to do 3C0, 3C1, 3C2, 3C3? It's 1, 3, 3, 1. Okay. Everybody doing this? Because this is not a lesson you want to try to figure out on your own. Then we're going to do, it was a to the third, right? But do we have an a? We have an x. So we're going to do x to the third, x to the second, x to the first, x to the 0. Then we went backwards with b's, but we have no b here. What do we have? So this needs a 4 to the third, a 4 squared, a 4, and no 4's. Then we throw pluses in between and we're done. Simplify for me. First term is x cubed plus 12x squared plus 3 times 16, anybody? 48x plus 4 to the third, anybody? 64. I didn't do a bit of FOIL. Makes me happy. Now, did I know ahead of time? There's no symmetry, I had to actually do it out because there was a 4 in the question, okay? There was more numbers than just an A and a B. All right, let's try this one. Row 4. Who knows row 4? Oh, 1. What's wrong? Somebody got a question? Okay. Now, the first term, our A today, A on this question is actually a 3x. So there's 3x 4 times. Be careful. That is not 3x to the 4th. Okay, then there's a 3x how many times? A 3x twice, a 3x once, and no 3x. What about the second term, the b value, which is actually a y on this question? If we go backwards, there's 4y's, 3y's, 2y's, 1y, and no y's. And all these terms get added together. Help me out. Where did I get an 81? That 3 is also to the 4th, right? Nobody going to forget that? So this is a 3 to the 3rd, which is 27 times 4. 108. X cubed and a y. This is a 3 squared, which is 9 times 6 is 54. X squared, y squared. Nothing is on the coefficients is squared here, so it's just a 12xy cubed plus a y to the 4th. Yes. No. What are you using if you don't use the triangle? Say that again. Are you using the C, the combinations, you mean? Okay, yeah, it's the same thing. That's how we got those numbers on the triangle. By the way, there is a program called Binomial Expansion that some of you have in your calculator does this. That's fine. I can make everybody use the calculators in the case and make sure it's not on them. Or you can just do the lesson and I can pretend the program doesn't exist, okay? But please make sure you know what you're doing. All right. This one has an interesting twist. It has a negative. You got to be a little bit careful with these. I'm going to say that and then I'm going to show you how you really don't have to be careful, okay? Because if we write this out, this is what Faisal's talking about. You can do 6C0 and then you'd have an m to the 6th. And the next term would be 6C1. I already explained this. This is how they generated the triangle. And then you'd have an m to the 5th and a negative n. The next one, let me move this out of my way. Definitely do not need that in the way. 6C, well, it's going to get easier. 6C2, m to the 4th, and a negative n to the what? Then what's the next one? Okay. Then how do you get those numbers? Just to get the coefficients then? Yeah. Okay. I'm roughly doing the same thing. 6C4, what do we have them? M2 negative n to the 4th. I got two more terms. 6C5 m negative n to the 5th. And what's the last one? I think that's a big 6. 6C6 and negative n to the 6th. All right, we don't want to type all this. Okay. What's the first number in any of them, guys? 1. So this is m to the 6th plus. Now, be careful here. What's the second number in row 6? 6. But what's back here? A negative n. So we end up with or negative 1. So we actually end up with negative 6 m to the 5th n. All right, what happens when we square this negative? It's going to become positive. Okay, 6C2. Type that one in your calculator. I'm only going to make you type 2 in your calculator. This is 15. Okay. So we have a 15 m to the 4th n squared. Why wasn't it negative? Because the negative is squared. It becomes positive 1. All right, one more type in your calculator. 6C3. 20. Okay. Positive or negative when we multiply by a negative 1 to the 3rd? It's negative 20m3n3. Now, 6 things taken 2 at a time or 4 at a time. It's the same difference. Because you're either taking 2 and leaving 4 or leaving 4 and taking 4 and leaving 2. So it's going to be 15 again. Yeah. So it's 15m2n4. What's the next one? Look at the pattern. 6, and it's a negative 5th. Negative 1 to the 5th is negative 6m n to the 5th, and a positive, this is a 1 n to the 6th. Okay. That would not have worked out as easily if we had to deal with other coefficients in this problem. In other words, if the m or the n had a coefficient. What I want you to see from this example is that the signs alternate. Anytime you have an a minus b, it goes positive, negative, positive, negative, positive, negative. So just at the end, make sure your signs are right, okay? I'm going to skip this one. And I'm going to skip this. This is the actual expansion formula. If you wanted to know, this is kind of what Faisal's doing. Well, same thing that we've been doing. All right. It's called the binomial theorem. This question says, what if I wanted the fifth term in this expansion? How does that going to go? 7c what? Fifth term. Be careful. It's term 0. It's 7c0 for the first term, right? Remember? If we want the seventh term, holding up 7 fingers here, we're going to have 7c0, 7c1, 7c2, 7c3, 7c4, 7c5, 7c6, 7c0. Okay? It's to the 7th power, but there's 8 terms. Okay, we want the fifth one. 7c0, 1, 2, 3, 4. 7c4. Just making sure you're getting where that's coming from. Okay. And because there's no coefficient other than 1 here, this is just the coefficient. So we type that in and we get 35. Now we're going to do one that's a little more complicated. We're going to do this one. This is to the 6th, and we want the 4th term. Okay? So it's 6c, what's the 4th one? 0, 1, 2, 3. We want this. But then there's a 5a, this is a 20, okay? There is a 5a. How many times will that happen in the 4th term? There'll be a to the 6th, a to the 5th, a to the 6th, 5th, 4th, 3rd. Now, if there's 3 of those and it's to the 6th, how many 2b's does there have to be? 3, because these have to total 6. All right, so what's 5 to the 3rd, somebody? What's 2 to the 3rd? Okay. If you multiply that all out, you get 20,000. It would have an a cubed, b cubed, but what did the question actually ask for? Just the coefficient, so it's 20,000. Okay, we have 2 of these to do. Ready? We can do this. It takes my fingers, though, for me to do it. I have to count. Okay. I need the 4th term of a plus b to the 6th. So the first term is 6c0, the second term, third term. This is terms 1, 2, 3, 4 is actually 6c3. It's the same we just did, which was 20, yes. Okay. Then what? This would have an x to the 6th, x to the 5th, x to the 4th, x to the 3rd. But it would also have a what? 5 to the what power? The exponent powers have to total 6. Okay, if think of it this way, the first term would have no 5s, right? The next one would have 1, 2, 3. Yes. Because the first term would be an x to the 6th, right? Then an x to the 5th, x to the 4th, x to the 3rd. Going the other way, this would have 0 5s, this would have 1 5, this would have 2 5s, and this would have 3 5s. Better? Okay, this was a 20, this is a 1 to the 3rd, and this is a 5 to the 3rd. If we multiply that all out, we get, that's the coefficient. It would be an x to the 3rd, but we don't care, it only wants the coefficient. Okay. This one I have more trouble with. We need to get down to an a to the 3rd, right? So the first term, is that an 8? I want to cry a little bit. Okay. The first term would have an a to the 8th, 7th, 6th, 5th, 5, fourth. Okay, 3, 2. Okay, this is the first term, second term, fourth term, fifth term, sixth term. It's actually the sixth term in the sequence, if you care. I don't really care. I need this term, though, the one that has an a to the third. Okay? How many? It's got to have 5 b's, yes? It says that right there. We need to figure out the coefficient, though. The c thing is what we need to figure out. This one would be 8c0, 8c1, 8c2, 8c3, 8c4, 8c5. So it's 8c5 times, they told us right here, term A is there 3 times. And they told us right here that term B is there how many times? 5 times. So as far as a coefficient goes, this is 56. This is 3 to the third, which is 27. And this is 4 to the fifth, which is like 1024, I think. But multiply it all out. Right. How about we write it all out? We don't need scientific notation. 56 times 3 to the third times 4 to the fifth. 1548288. Did you figure out what you did, Benji?
Yeah.
Okay. Needless to say, guys, I did not assign 15 of those for homework, okay? There's like 2, 3. All right. Write it all out if you have to. Hopefully it doesn't have to the 8th, okay? All right. Let's do this one. Number 8. Okay. Do you want to do it with C's or do you know row 4? If you didn't know that, someone explain to me how you would find that. 4C0, 4C1, okay? Everybody good? Okay. Now what? The first term has a 4x to the fourth. Let me do this in a different color. The second term has a 4x to the third and a negative 2y once. I'm just not going forward and backwards this time, trying to get you to see this. Okay, this one has a 4x one less time, which would be 2, but it has a negative 2y, what? One more time. The next one has a 4x one less time, which makes 1 time, and a negative 2y one more time, which is 3 times. Then we're out of 4x's and we just have a negative 2y 4 times. Okay, what's the sign going to do when I'm all done here? Yeah, some positive, negative, positive, negative. Okay. 4 to the fourth, somebody? 156? Thank you. Didn't sound right. Plus, this one is a 4 times a 4 to the third times a negative 2. Does everybody see that? Yeah, it should be negative. And what's the variables? X cubed and a y. Okay? What about the next one? 4 squared is 16. Negative 2 squared is positive. 4 times 16 times 6. How much? 384? Then this one is a negative 2 to the third, which would be negative 8 times a 4 times a 4. 128? 2 to the 4th is 16. All right. Is your head going to explode? All right. That's all the algebraic fun. Now we're going to talk about what does this have to do with anything? Well, it has something to do with a kind of probability called binomial probability or binomial experiments. Okay? Binomial means two, right, guys? So the only way an experiment or a probability can be a binomial is if all of the experiments are the same, and if there's two different outcomes only. Please pay attention. Lots of things that are binomial. That's why there's such a huge study of this, okay? For example, if I have a multiple choice question with 5 choices, I don't think of that as being binomial because there's 5 choices. But the outcome is I either got it right or wrong. There's only 2 possible outcomes. You see what I'm talking about? Shoot a basket. Well, I might have a 20% chance of getting it, but it's either right or wrong. I either make it or I don't. I succeed or I fail. There's really only 2 outcomes, okay? This says the trials also have to be independent. They can't affect each other. What this says is you take NCX, which is the number of successes you want to have, the probability of success to the power of how many successes you want to have, the probability of failure. Okay, on that 5-question multiple choice test, what's your probability of choosing totally by guessing correctly? 1 in 5 or 25 or 20%, right? What's your probability of failure? 80% or 4 out of 5. It's just 1 minus the chance of success, right? So then this is 1 minus that probability and the number of failures you have to experience to get that. That's difficult. Let's go to an example. Okay, this one you don't have, so just pay attention. The probability that Andres gets a hit when at bat is 1/5. What's the chance that he doesn't get a hit? 4/5. 1/5 success, 4/5 failure. What's the chance, though, that he gets exactly 4 out of 10? That's 10. We want him to succeed 4 times, times the probability of success. How many times? 4. Times the probability of failure, though, how many times? For him to get exactly 4, he has to fail 6 times. You type that all in, and you get 0.088. All right, let's try one on the homework. Here we are. A golfer can drive a ball to the fairway 70% of the time. So his probability of success is what? 70% or 0.7. What is his probability of failure? Okay. What is the probability that this guy drives to the fairway on exactly 4 of 18 holes? 14. I can read, thank you. Can't read well. 4 of 18. So what's the combination we need? 18, C, 14. What is the number of successes and the probability of each? 0.7, and we want to succeed 14 times. What's the number of failures, or the probability of failure? 0.3. Number of failures is 4. Okay, see if you can type that in and figure it out. I got 0.16810, blah, 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 about 16.8% of the time. Everybody okay? Everybody not getting that? There's a way to do this with an app or a thing in your calculator that everybody has. Everybody's calculator has. I'm going to show you, but I want to do one more by hand, okay? The probability that a substitute teacher gets a job on a Friday during any given week in a certain district is 32%. So if the teacher wants to work, the chance of success is 0.32. Chance of not working or failing is what? 0.68. What is the probability that the sub will get work exactly 3 out of 4 Fridays? So how many trials? 4 trials. How many successes are we looking for? So 4C3 times 0.32 to the third times 0.68 once, right? Fail once. Gannon? Dwight? Okay. 4C3 is just 4, isn't it?
Yes.
I got 0.08913, so about 8.9% of the time. Yes? No? Okay. The next question is different. So before we get to that one, I'm going to go back and show you the shortcut on the calculator. If I go back to this question, on your calculator, there is something called binomial probability, and it will calculate based on the trials and the probability of success and the number of successes you want. It figures out the probability of failure all by itself, okay? We're going to go second and the vars key over by clear. Don't be tempted to just use normal. It's not the same. Go down to binom PDF. Now there's 2. There's combined probability and straight up probability. We're just going to use PDF today. Binomial PDF. CDF would be good for the next question, but it's complicated, so we're just going to do it this way. Okay, hit enter. Now, if you have a really old calculator, I'll show you what the screen's going to look like, but you're just going to type these things with commas, okay? So how many trials was this one? The golfing one? 18. Okay. Probability of success was 0.7. The number of successes we wanted to have was 14. Okay. Enter. It's going to look like this. 18, 0.7, 14. And you get 16.8. Okay? Everybody good? I just want to practice with these that we already know the answers are right. Move on to this one. Okay? Now, I'm going to do it again with that same button so you remember where it is, even though I'm going to show you why it's faster in a second. Second, vars, all the way down to binom PDF. Okay, what are we putting in this time? 4 trials. 0.32 was our probability of success. The number of successes we wanted was 3. 4.32 and 3 with commas if you have an older calculator. We get 0.08912 blah blah blah. Everybody okay? All right, the next question is a little more complicated because first of all, the wording I found troublesome, but it says, on average, a basketball player misses 3 free throws out of every 8 attempts. Okay? So I'm going to go with the probability of success is 5 out of 8, and the probability of failure is 3 out of 8. Is that okay with everybody? I think it's actually a tiny bit shorter to want to fail on this question, but it doesn't matter. if the player attempts 5, so what's that telling us? The number of trials, right? What is the probability that he misses no more than 2? Okay. How many times he's going to shoot 5? He could make all 5. He could make 4. He could make 3. He could make 2. He could make 1. He could make none. He misses no more than 2. Okay? How many of those does he miss out of those possible outcomes? If he makes all 5, he's good, right? If he makes 4 out of 5, he's good? 3 out of 5? What if he makes only 2? Then he missed, right? So all of these possibilities add up to missing no more than 2. Okay, which means he makes 3. Right? I'm doing makes 3. He's got to make 3 to make this be true. Everybody good? He can make 3, make 4, make 5, and he'll be good. He'll miss no more than 2. If he makes 2, he still missed too many, etc. So this is what we need to do. We need to find the probability he makes 5, 4, 3. Okay, we're going to do it with our calculator, and I'm going to show you the shortcut. I'm going to go to Binomial PDF, and he's attempting what? 5? Probability of success, you can do 5 divided by 8. It will take it. It's 0.625 if you want to type it in as a decimal. I'm going to start with what's the chance that he makes all 5? Because that would work. We get, I'm going to write down about 4 places here, 0.0954. Okay, then I'm going to cheat and go second enter and just go back and change that last 5 to a what's the chance he makes 4 and hit enter. And then I'm going to go second enter. And what's the chance he makes 3? Because that would still be a successful outcome for us. And then we're going to add all those up. Anybody already do that? .724 something, or about 72.4%. Now, those of you who are in probability or AP stats, I would hope, would know that there's a way to find that. It's actually 1 minus, and that's the complicated part, I can explain in a second, the combined probability, which is this one, that in, was it 5 trials? Yeah. Okay, it's the chance that he is successful that he misses 2 or less times is 1 minus the probability that he makes it more than 2 times. I have a really hard, this makes way more sense to me adding up the probability. What? Yeah, that's why this makes more sense to me. He's successful if he makes 5, 4, or 3. So I just find those, add them up. Okay. The way the question is worded, I think we could have figured it out a different way as well, because it wants this, he misses 3 out of 8. So if you switch those around, it's all complicated. All right. This is the assignment on this stuff, okay? 2, 3, 7, 10, 11. Okay, then this stuff's probability out here, I think. I didn't assign very many of those icky algebra ones, all right?